The FFmpeg Filtergraph. I taught this to multiple groups of devs in my previous startups, and this part was usually the most confusing. It could be because it's the first thing that's really FFmpeg specific in what we're teaching here. So I try to incorporate as many examples as possible, and I'm leaving extra slides for questions. First of all, an apology for all the weird white colors in my presentation. I test my slide for colorblind compatibility, so it's really not an aesthetics choice. It's about being practical and inclusive. I also try to make sure that I use fonts that distinguish one from I and L in all of the cases whenever I'm using code. And if I missed it anywhere, please send me a message. Back to the topic, the most common example you'd usually find for FFmpeg usage is a single command using a single filter, something like this. This example, which basically just scales your video to 1280 by 720. And even though I made this one up, I'm sure there are plenty of people who had this as their Google search result. So obviously the I stands for input, it's followed by a file path. VF stands for video filter, and it's followed by a filter graph, this entire thing. And this specific filter graph only applies to video streams in the provided inputs. That's what the V stands for. Scale is the filter name, and you see it equals 1280 by 720. Whenever you're providing a filter with parameters or options, as they're called in the documentation, you need to add an equal sign. And the options are delimited by a colon. What you see here are 4 more FFmpeg commands that are alternatives to the one we just saw. And all of these commands not only have the same results, they do the exact same thing. Filter options have a default order, meaning you can skip the option name, as we just did in the previous slide. No option name anywhere. But if the filter you're using has more than one option, those options always have a name, which is what we're seeing in the first variant, W for width and H for height. In the second variant, we can see that you can use any order of options whenever you're using names. And in the third option, you can see that you can also mix. Even though this is possible, I do not recommend it because it can be confusing and unclear. Lastly, instead of using VF, which only works on video streams, I'm using filter complex, which works on every stream. See that now I have these additions. This is because when we're using the filter complex, we have to be more explicit. It can run on every stream. So these are the input stream and the output stream. The stream names are always encapsulated by square brackets. I know this suddenly just got a bit more confusing. Bear with me. This mock of an example is still just a single filter. The rules are very simple, and I'm going to read them out loud. I know it helps. Each filter in the graph is comprised of an input block in blue, the filter itself, and the output block in red. These inputs and outputs are always streams. These are our so-called variables, and it's really important that you think of them as streams because that's how they actually work. Our variables or streams are always encapsulated by square brackets. I mentioned this. And when you address a variable as an input, it must already exist. But when you name your output, you're implicitly creating it, meaning that it shouldn't already exist. If it already exists and wasn't used, I'll elaborate on that later, then the program will shout at you and wouldn't run. Filters can have multiple inputs, for example, overlaying an image on a video or concatenating multiple streams. Those are examples for filters that would have more than one input. They can also have multiple outputs. For example, the split filter lets you duplicate a stream. It's a lot more useful than you might think, and that would have multiple outputs. And when you provide your filter with options, you have to add the equal sign. And those options should also be a pair of option name and value delimited by an equal sign. And those pairs should be delimited by a colon. So in this example, what we're doing is concatenating 3 video streams into one video stream and then outputting that stream into a new video file. You can see that our files are addressed by their stream index. The order matters here. You see, I have this file and this file and this file. The order in which I name them is going to assign their index later. If I change the indexes around here, I would have basically just changed the order of the concatenated outputs. V stands for video, obviously, and the other possibilities are A for audio and S for subtitles. You might have noticed in the map section that I'm implying you can have multiple outputs in one command. That's because you can, but it's not a very common thing to do, and I don't think we should touch on that in this lesson. The other thing is that you can't have a dangling stream. I mean, if you output a stream with one of your filters, you aren't doing anything with it, dangling, FFmpeg will think you made a mistake, you probably forgot about it, and will prevent that graph from running. It has to have a purpose. Last thing that we should fix here is that we don't have any audio. So let's do that. Wasn't so scary. So basically, we just duplicated our filter, and we're now addressing the audio. Because these two filters are completely separate in the way that they work, we need to separate them, and that's why this semicolon is here for. There's also an option not to use a semicolon when you want to keep on editing the same stream over and over, adding another filter. That's called chaining, and also our next slide.